Hi, good morning everyone on another Advent of Code challenge. But this time I changed the format a bit that I am not surprised with the puzzle, mostly because I know that my videos are way too lengthy. I want to shorten them up and I already started the task like barely by creating the repository, importing some stuff. And what is the most important, I figured out the passing. So I'm not waiting like hour and a half just on passing. And today I would approach this puzzle in very different way than before because I want to be a bit tricky and show you how to solve actual puzzle thing, not production like thing today. So first of all, we have this crappy input, and this is the great example for what I want to show you, because yeah, you could think about passing it properly, let's say with norm, and this would be okay if you are creating some domain specific language like that, but it would be pain in the ass to do so, especially if you want to support main operations and so. And this input defines you some monkeys having some items. They're having some items being numbers, and every iteration they would basically transform this those numbers. And there's operation they would use to transform. And yeah, it looks already scary that you could have couple operations, and then you have some tests, some another operation which is divisible. It looks scary, and then you have some branches which could be formatted differently if you think about that. And then you read that there is kind of a sequence they are following. Every round is monkeys are throwing those items to each other, right? So when there is monkey's your turn, it takes its first item, then it applies the operation on it. Here would be 79 times 19. Then it divides it by 3 as far as I remember. Give me this thing. Yeah, this is then divided by 3, round down, which is actually to our advantage that we don't need to deal with floating points. So this divided by 3, and then it checks this test. If test is true, then it goes to this second monkey, and if it's false, it goes to another monkey. And it looks like the input is very complicated, but let's think about it for a second. First of all, first thing you want to do, if you have kind of this thing, you need to look at your final input, you'd handle, which I have here, and check if there are any tricky cases you want to cover. And first of all, you can actually notice that all monkeys are prepared exactly in the same time, in the same format. 6 lines and exact same order, even though true or false doesn't matter because they are in exact same order. You can completely ignore this. And if you take a look, even ordering of monkeys doesn't matter because they are always bottom to top, right? Sometimes it would matter if you're creating a proper software, then you maybe want to store it in HashMat, but here, no, it doesn't matter. So what we do, we take 6 lines per monkey. We want to filter out empty lines because we have no final empty line, and it would be a problem if we would not filter it out. So we just filter out empty lines. We take 6 lines per monkey. We completely ignore the first line. Then we have starting items, some operation, some test, and some true false. And if you look closer, how to pass starting items, we could do some norm stuff, but no, we can look for the colon, right? We look at colon, split at that, take this, split the numbers on commas, pass integers. This is how you can approach this kind of puzzles, because those whole things are very strictly formatted in very strict way. If you look at operation, you could you could be tempted to just split on colon and then do the whole whole parsing of equation. But no, equations are always, at least in my case, if your input is different, then sorry, you need to do some more work. But it's always new equals old operation, operand, but there is a catch. Operand, at least for multiplication, can be old, which means this basically means squared, right? I don't know if I don't have it for add, but actually this is so trivial to add it for add that I have it here. I will show you the passing in a second. I just want to briefly talk about how I did it. Test is like always divisible by number, and you just go to the end, you will find last space, you take this, you parse your integer, and exactly the same for those lines. The only difference is that this I want to be my integer. I use U128 as in all puzzles, and then here I want usizes because those are indices in my vector, so I want them to be usizes. So this is as simple as that. So how do I pass it? I want to show couple tricks I used. First of all, I decided to go with nightly here because it has one nice feature I want to use, which is iter array chunks. I noticed it before. This is something new. I was not even aware of the extent of that, but I checked it out. So how it works? We'll use it for splitting those iterator of lines. You'll see it in the moment. But this is something which is only in nightly you can enable it implicitly, and this would very much helpful in this example. I also use the create call derivative, which allows us to be a bit trickier with implementing our debug, which is useful for debugging. For now, I wanted to just print out our input to check if it is loading what I want to load properly or pass. So I created my monkey struct for the whole program with everything we need. Items, all right? So vector of our items. Operation, which is the trickiest one. I will get back to it in a second. What is that? But I have test, and it is always divisible by. I don't need anything fancy. I just want to have it a number here. I will check with modulo the number and check if it's 0. Then true branch, true, false. And I already added inspections because in the whole task, at least on the part 1, I don't know if maybe we would get it out of monkeys and modify it a bit, but what I want to do in the whole part 1 is to count basically how many times monkey thrown a number. It is called how many times it inspected, but the idea is that in every round it takes a number, inspects it, and inspection is this whole process, or at least looking at it. So, but basically, how many time monkey inspected is equal to how many times monkey thrown the number to another monkey. So we want to count this, and we need to do it after 20 runs, basically. So the easiest thing I think is to keep the inspections with the monkey, and it would be starting with 0. But what is this operation? So we could do like the simple thing to do is to keep an operation here as some kind of enum being operation, which is times or add, and then the operand, which is either number or old, right? This is the easiest way, but later calculating this operand or evaluating it would be actually like very branchy, I would say. We would have a couple branches to do this. It would not be so easy. So instead, I took, I could even do better with opfn. I would have a box over opfn. And what is box? Box is pointer to a heap. And I will tell you why I need this thing for in a second. So what is opfn is more interesting. So in Rust, you have those tries. Forget about the din keyword for a second. we have a trait called fn, and this trait is anything which looks like a function, which could be called with my inside 128, and it gives me back another number. So this is this trait is anything function-like from int to int of this type, right? This is type. This din keyword right here makes this trait into what's called the trait object. So this is a dynamically dispatched object which implements this trait. I don't want to go into details. If you know dynamic dispatching from other languages, this is basically an object which has all the functions defined in this trait virtual calls. And in this very case, it is just call this function. So this opfn is a type, it's some dynamically dispatched type of a function which can be called with this. This is basically any function callable with int, giving back an int, and because this is din, it is dynamically dispatched. Not in compile time, which is called monomorphization in Rust, it's dynamically dispatched. And the problem is that this type could be any type, so we don't know its size. Because we don't know its size, we cannot keep it in stack. Because on stack, we need to know the size of an item, we keep it on the stack, right? And because we don't know the size of that, we need to use box to handle this. On the heap, it is not needed to know the size of an item you keep it there. So you can just box it to keep the function on heap. And this is all you need to keep any function-like object which you would dispatch later. And this would help us because we will build our function while passing this function. We will build it. We will create a closure with that, and we will enclose this closure in this box to have another object. But we'll go there in a second. So first of all, I prepared this function per line. I completely ignore the first line. I just skip it completely, right? And what I do is I pass starting it item. So I pass this. First thing I do, I split once. Split once differs a bit from split in the way that split gives you an iterator of results. So it could be 1, it can be 0, it can be 100 of items. Split once finds this token only for the first time, and it returns you a pair before the token, after token, right? So this split once gives me this on the first item, which I completely ignore, and this would be this, which I can't ignore, but I can trim it because I would like to lose this space. So I do this. Actually, I don't need this trim, but if you pass like this, trim is very fast function, which you probably can ignore in terms of efficiency, but it makes you, let me close, it makes it easier to reason about this and avoid mistakes. You just don't want this this spaces on left or right. You can also L or R trim if you want to just remove left or right spaces. Anyway, I have my items, then I split them, this time not once, I can have many, split them on commas. I map my results because this split, I do filter map. So what I filter map through? First I trim, because for example this 98, I would have this, it would fail to pass, I need my number only. So I trim every item. I could probably split on comma space, but yeah, this looks easier, cleaner. Then I pass it into my thing. It would figure out the type, which is this. I have no HL. Doesn't matter. So it passes me to my integer type, and I use OK to change my result option, and then I filter map. So if something fails to pass, I just filter it out, right? and I have my items. I collect them into my vector. Easy enough. Parse operation. This is very interesting one with this closures. So there are a couple things. First of all, I pass into this pair. I return an option because I can fail on many stages. So I just on failure I would just return known, right? Not the best error handling, but this is very common for puzzles. Just ignore errors, right? I talked about it before. So what I do here, I take my line, I split once on alt, because I know that there is the first alt is this first operand. Then I have operation. I ignore the first element here, right? So now I want to split this thing actually, into operation and value. So I split it once on the first space, but I trim it before because I want to make sure that there are no leading spaces on my operator, right? So I have operator, I split it once, and then I match, and I match on two values. That's why I wrap it into pair, so I can match on two values simultaneously. First value is my operator. I trim it. There is no chance actually I need this trim here because I already trimmed it on the left here and this trimmed it on the right. So this trim is very optional, but yeah, just to make it 100% trimmed, we can use it. So this is operator, and the other one is value, but I don't actually match on value. I match on the fact if value is alt. Another way I could do this, it could be this. I can make this. So I match on value being taught. I think this is even more clear. I don't know why I went the other way. And here I bind value. This is just value being not the alt literal, right? So if it is plus alt, then I basically create a closure which is x times 2. I need this U128 because it's assumed it is some E32 by default. It doesn't understand those white literals by default, but doesn't matter. So this is basically alt plus alt, which is alt times 2. Very easy. Ignore this for a second. I will go back to this. Come back. Then times alt. Very much the same. Add and multiply, but not with alt. How this works? First, I need to pass my value, but I pass it only once, and only now. If parsing fails, I just ignore it, right? And I move this passed value into closure, and I add it. I need this move because if I don't, even though U128 is copy, closure still takes it by borrow. And, you know, I return this owned closure from the function, but my value lives only up until this bracket. So I need to move this value into the closure I create, and I return those back to your box. If it doesn't match, which basically means invalid operator or invalid, I mean this would always match here, but here I can have some invalid operator. I just return none, and at the very end I need to wrap my my closure into some because I return option, so I need to wrap into some. And now, why do I need this? This is the thing that every closure creates its own temporary type, right? And because of the fact that every closure creates its own temporary type, this line and this line and this line and this line, all of them return different type. But for the match, all branches has to return the exact same type. So what I need to do is I need to return some common type from them. And all of those could be basically converted. Every object, every boxed object can be for free. It's a trivial conversion to convert it to box object over dynamic trait it implements. Right? All of those implements but the op and dynamic trait. right? Because there are closures from number to number, easy enough. So I just converted the first one, but why I don't need to convert the other ones? I mean, this is a bit of type collision magic. So first, Rust compiler sees that the first branch returned this, and in the second branch, if the type elided by default by this is different that one returned from that, which is different. This is some closure type, and this is boxed dynamic, boxed object trait type, but it tries to basically perform as the type you expect. It cannot do any into magic or some explicit conversion magic, but it can try to do this as expected type for the first branch. So this way, all those branches, because they return type which is compatible with box OpenFun, they align to proper thing. Pass test, pass branch, those are basically very same thing. I just have another type. For simplicity, I copied this. They trim the line. Just, I want to get rid of any extra spaces, especially on the right side. I split it on the space, but I you are split ones, because split ones would, even after trim, so I start here, it would split me on this. I want it to split me on the last space on the right. Yeah, there is no spaces here because trim took care of that. I take the test, I ignore the first part, I pass the test. Right? Easy enough. And then I have my input function, which passes the input. Traditionally, I go for standard input, I take my lines, I filter out any invalid lines which I do not expect at all. But I want to, basically I do it only to change result type into string type. And yeah, that's all I want to do. And I filter out those lines so I do not need to deal with them. And then I do array chunks. And array chunks is a very fun function which, if you have iterator, returning some objects or strings, like I have strings. So array chunks takes me those strings and groups them in kind of like chunks, but the type under the iterator is, as you can see on this type hint generated by Rust Analyzer, it is something representing iterator where the item is string, because string is the type of L, right? And this is an array of string of fixed size. And the question is kind of, how did Rust figure out what exactly type is, what is the N here? Right after that, I do filter map and I try to deconstruct this array. So it knows that the size of this chunks has to be 1, 2, 3, 4, 5, 6. And it can magically figure it out. If I add here another field, it would split me into chunks of 7 lines. And I could do this to avoid this last empty line, except after the last one, after last entry, I will not have this empty line, and then I would need to use the function reminder or something. That there is a function to take out the last array chunk, but I really didn't want to deal with that. So what do I do now? I have my lines, 6 lines, and I completely ignore the monkey. I underscore it. Then I pass my items. Then I pass my operator. Test everything. Collect it into my monkey. Set inspections in my monkey to 0 at the very beginning, and so on. And this is what I did already, just to do not struggle with any kind of passing things. So we can start the interesting part, which is part 1. Input being a slice of monkeys. Input being, I will actually copy it into that because it is so obvious. I would need to modify it. So how I approach that? There is a very nice function in iterator. We often used false, we used some scans before, it's useless, but there's another function I like to use in this kind of situations. It's std iter successors. So how does it work? First, we need to put it the first item of the iteration. I want to generate first thing. What I want to do here, I want to generate the iterator where every item would be the state of the monkeys after each run. So iterator over runs, let's say, right? So the first or the 0 round, I'm not sure exactly how it's after round 1. So round 1 is index 1 because round 0 would be our starting position, right? It's input. This is our starting position. This is our 0th element of iterator, our very, very first state. Then what I have is a function which takes my input, my previous value, right? I believe by borrow. Yeah, by borrow. See this successors by borrow. And so previous. And what it does, it returns another value of item, another item, after the change. Some, because it might end at some point. Our iterator would be actually infinite, because we always can proceed. So what do? We need to transform to perform some actions for every monkey, and we need to figure out how do we approach it. Every monkey would first I would first map all its items currently holding. In the task, you have like first take the number, then do operations, then throw it. But calculations between numbers are completely not depending on each other, so you can just map all of dust, then for all the numbers, decide where to throw it, and then throw it. This is the easiest way, in my opinion, to do that. There's a problem that we cannot like easily do it in our fault or scan or mapping manner, because if we would try to do this like mapping all those monkeys, then monkey 0, while executing it at 79 processing, would try to throw it to, I don't know, monkey 3. I'm guessing right now. So it would like to modify monkey 3, but it cannot modify monkey 3. So we need to we would need to work on indices at some point. We want for each monkey, a round is going through each monkey, but we need to modify the other monkeys through my round. So what I would do here, I will go and I would make my state being previous clone. I would just yeah, this is vector. So I would just clone the vector to my new state, and while modify the plates. We are trying to avoid this, but sometimes it's really difficult to avoid. So now we would okay, it's double reference for some reason. Let me think about this. Why pref is double reference? Why input is Let me check the type of input. Input is vector. So previous should be borrowed to vector. I know how to deal with that, but I just need to go like this. So oh, I know why. What happened? Monkey is not clonable, and because of that, it tried to clone the reference. Oh, I cannot clone a function. That's kind of a shame. It made my solution way more difficult than I wanted it to be. So I need description of monkey actually, which is let quickly monkey description. We would differentiate monkey description and monkey state. So monkey state would be items and inspections, and make them clone. So this is what I would clone. And monkey description would be all the things which describes the monkey, and it would be never cloned. It would make it a bit easier. Input would be this monkey state, right? Then let monkey description is monkey description. Like this, and now we return description and state. So after all, it's not so difficult to handle. This vector over let's make it this. Okay, so what we'll do here. Our successors, I never more want to deal with any kind of I don't want to care about my monkey state at all. And what I actually want to do here, do I want to unzip it here? I think I want to. So I want to keep my states and monkeys in separate vector, and it is very often very bad idea on production, but for Puzzle we just know they are very much parallel. And what we do here, instead of collect, we call unzip. And unzip takes this kind of iterator over pairs, and it collects it to collections, to pair of the collections. And this way we have monkey description. This can be nice, and states, descriptions and states. And this we want by ownership. So what happens then, I move some states. Okay, now it's going easier. Okay, we have my states, because this is actually the only thing I want to modify. I want to do something for every monkey. So for every monkey, first of all, I told you I would need to go with indices, and this is why I need to do that. For index in 0, I don't want to check if it has any sense right now. And by the way, here I would just modify previous. No, it is by let state is previous clone. I would just modify the previous state and return it. In general, I really like to avoid this kind of stuff, but here I don't think I can. So for every monkey, first thing I want to do for every monkey is to map those through the operation to the operations. So, and I basically want to also remove those items from the monkey. So let items would be state. I take state ITX items. I will go iterate over them into iters. Into iter. I map them over descriptions. Item over descriptions. Index. Operation item. Exactly. And I collect them back. Monkey description has of item. Oh, this is a box, and probably it needs to be the reference to use extract item. Exactly. It doesn't know what type is item. For now it's vector. I mean, we don't need to pass this because I think, well, let's see. I think it would be removed later. Cannot mode of index. What? Wait a second. Cannot mod out of index of monkey. Why I cannot? I have my monkey state. It needs to be mutable, it doesn't yet know it. Yeah, I think. Let's do it like this. Monkey would be mutable state. Yeah, now it's better. Because what happened, I think. Monkey. Yeah, it cannot move monkey items. Which kind of makes sense. So what we would do, let items is I didn't want to do that, but take right. What happens? Right. So let me take a look at the take function from Sublime. Before I will tell you what it does, I want to make sure I understand it properly. Yeah. So what it does, it takes me an item from mutable array, right? And then do I even want to do that this way? Or I think I want to do that this way. So I took out my items field from my monkey, but I cannot just extract it. I need to leave somewhere there. But hopefully after the whole cycle, I want to leave there an empty vector. But I need to construct a new vector. I will do it in a more fancy way. Instead of all this thing, I would do it very similarly, a bit different. Oh, I would do for monkey. I would just modify them in place. In state. No. All item in the table states items. So this would make this that item is mutable borrow over items. I would just do this. I would map it to item as description borrow over item, and one thing we forgot about, and divide it by 3, and this would also immediately profit items. So it would floor them to the nearest integer, which is what you want. And do we want to just drain those items? Or do we want to just partition them? We show the partition thing. No. Slice. There's partition slice, right? No. There's no such thing as partition. What I wanted to do, Iterator maybe has it. I'll try this trick. So now what we do, we make it like, but I would borrow this guy mutably. I cannot borrow two guys mutably, right? Let me think a bit. No, I cannot. So now what I would do, I would create true and false, basically. I want to split our numbers true or false. How do I do that? Basically, I go to my state IDX, I go to items, and I don't do iter. On vector, there is this nice iterator called drain. So let's go to vector, drain, and this is the iterator which takes me which iterates over the items and then removes them from my vector. So it would, if I would iterate over the whole thing, it would, if I iterate over the whole thing, it would remove all the items. I can draw everything like this. So I just don't collect those. I do not create the intermediate additional intermediate vector, which I destruct immediately. I would anyway create those two vectors, but one location less. Probably it doesn't matter this much, but what do I partition against the fact that my x percent description dot test is 0. This is what I partition against. Partition probably, yeah, it just wants me to make it vectors, or it needs to know what it collects into. You for sure remove those type hints. And then I do state. Yeah, why not? Monkey is, let's say, idx. It's just to avoid this much of indexing. This. I just try to simplify it just a touch. Yeah. And what I do now, state description of a true branch, I extend them with this. False branch, I extend them with Fs. Can I get rid of that? I think I can extend only with vectors. No, I cannot get rid of that. So I will not. I will leave it. But one last very important thing is I need to calculate the inspections. So this is the core thing, right? So what I do right after those, I know that it would inspect all of its items, so I just go with monkey items len. Add this. So now I do it for every monkey. Every monkey just throws items to its next barrels. And this is my new state. Looks properly, but it's not the whole part one. I have my successors, and what I need here, I need my 20th round, only 20th. So I would just skip first 20 runs, right? I can easily do that because why I can do that? Because wait, 20 not 19. Oh, that's the question. Because I have additional one state 0, state initial state, right? Then I will go next, unwrap or default, which would be empty vector. And it should return me vector over states. And what I need for my further calculation is only my inspections count. So I can iterate over my vector. I can map it to inspection, but I do not sum them yet. This is not what I do. I want those inspections in some vector. So let inspections this is inspections by monkey. Mismatched types. Next is option vector monkey state into iter monkey state. Why the collect. I want to collect those guys. Right. Skip next as an iterator. Can I? Oh, I can just use end, which is next. End 20 because it's 0-based iteration. Nice. So I collect those guys. What I do next? I want to figure out my two highest, lowest. Yeah, I need my two highest. And you could be tempted to just sort them, which is a way. Except sorting is not the most efficient thing to do this here, because sorting sorts all of your elements and you don't care about your order of your elements. You care to know which two elements are the highest ones. So there is algorithm which allows you to have your algorithm, your slice or vector, which would be need to be mutable here, not exactly sorted, but you guarantee that element which is m in order would be on m place. Everything beyond that element would be higher than this element, and everything below the element would be before that element. And this iterator is implemented in Rust. I checked it before, so it is select env unstable. You can do it by key also. We would just use the easiest thing here. And the problem with this is we want, if we pass here like to it, you see it's sorts in ascending order. There are two things to get away with that. First of all, we can use env unstable by, and we can define our ordering manually, right? So here we can actually use this, because this exactly shows you. So if you select unstable by with this reverse comparison, then it makes sure that the second item of order is on the second place. See, here it is phi. It guarantees that the second index of third in our natural language, but the item of index 2 in terms of ordering is on the second place. So if we sort them, one would be on index 2 and it is on any of those forms. See, and everything which is bigger is on the left in this case, because we reversed comparison, and everything lower here is on the right. It is really worth algorithm to be known because it's way faster than sorting, and it solves most of your problems, because it's often that you don't actually need sorted things. You just need nth item or n biggest items, and even if we would like to multiply 3 of those, we don't get the order, we just want to be sure that those are the biggest ones. So select nth unstable, we use by, we want one with the index 1, so 0 would be bigger than 1. And I want to reverse, right? So BA. And now we know that first indices in our slice would be for sure the biggest two biggest items. And in fact they would be sorted, but only because we have guarantee that index before would be bigger than the one we are looking for. So in this very case it is guaranteed to be sorted. Yeah, let's be fancy. Not that it is the best way. It is more expressive. Instead of multiplying those things, we just take first two things, iterate of them, and whatever. I'm wondering if I can even do that. Is product defined on sites? No. And now a couple things we want to do. I will just unwrap result here. I could just return. Can I return option? Like this. No, this is the thing. I don't want to figure out the result type. That's why I unwrap. And it's in description and states. Is it okay? No input. What? Wait, what? Input can fail? Oh, an input can fail. Oh, okay. Then print like one. Yeah. And let's hope we are on the. Okay, looks fine. I already checked before if the loading is okay. That's why I was pretty sure that it won't parse it properly. Let's see if we have some crappy stuff in our implementation or it just works. Yeah, this is good. And now pass 2. This one, sorry, I'm not prepared with. But in fact, you believe that monkey inspection didn't damage an item. No longer causes your worry level to be divided by 3. Unfortunately, that risk find another way to keep your worry levels manageable. And this way you might fatigue. Oh, my daughter is now having a fight with my wife. Sorry for those noises. At this rate, you might be putting up with those monkeys for a very long time, possibly very long runs with. Yeah, sure. Oh god, so modular computations. We need to have a monkey. There's the thing. This whole thing was done so our numbers here are not growing like over our limits, and using any white type would probably be not the best idea. I mean, we could do probably some, very big types here and it would work, but this is not the smartest way probably. The thing is that how many monkeys do we have? 7 monkeys, not too much. So there's the thing. There's thing which is called modulo arithmetic. And let me give you some very short introduction into math. I hope I will not mess something up. But here's the thing about modulo arithmetic. If you have a number n, x is x modulo n is equal some m. This is something you have given. Then you have like x plus some a, and you want to check if modulo n is equal to the same m. Our m is 0 basically. So yeah, you had this test, right? Let's assume that's true. All right, and so you actually want to figure out if this is true, if modulo m is equal to true. But it turns out that you can just, as long as you're only testing for this n, what you can do, you can always make x plus a mod n. Basically this. And this would always be this would be always the same. And this is kind of obvious because we are, this is kind of obvious. But that's also true for multiplying, I think, for multiplication. But there's kind of stronger thing. You can use some other m here. Let's call it capital M. As long as m is divisible by n. So what I'm saying to you is that my whole arithmetic here could be, to keep this low, I can just always modulo some m this and keep so our new rules tell us that we cannot do that. But we want those items to be low, and I always to keep the exact same results of this test, because what we care about is this test actually, the only thing, right? So if you want this test to be not changed, I can always do this modulo of m such as m is divisible by n. So the easiest natural way would be to do it modulo this test, right? There is a problem that then this value is thrown to some another monkey, and the monkey does computations on another output, and we did it like %3, so we mapped some number through %3, and then another monkey would do test over 5, and we didn't keep this modulo integrity here because we used different value for modulo calculations, which is not divisible by 5 or 21. So what I want to do here would be divided by 3 to keep it small. I know I am overcomplicating it, but I really don't want to go into math lecture. What I want to do here, I want to find such a number to use as a modulo here. I would copy this whole part 2. So because part 2 will be like very similar with some, I don't want to commonize this code because of where there would be some differences. So I want to find out some m such that the m is divisible through all the m's of monkeys. And there is very simple way to do that, which is I can multiply all the test values. And if I multiply, I could obviously find some smaller number, which is common divisor. I would do this only if it turns out that the multiplication is too big. But let's start assuming those are not so big numbers here, right? 7, 5, no, it will not be too big. So part 2, I don't have m, but I will calculate. The first thing is I would call it m, would be desk dot iter map. Exactly what I couldn't have better GitHub Copilot. I just need this, and then I modulo it here m. And I'm pretty sure this would work because, I mean, yeah, those numbers would not grow infinitely. I would cut them to some small m. And because I am testing only in this range, as long as I remember my math classes, this should be alright. I'm sorry. I didn't took any water. This thing should also, no, the only thing is, yeah, but this number is so low. It looks to fit in my big int. I have more runs. So I still work with 2 more Swanky Monkeys. So everything else is the same, except this number is bigger. Everything else should be exactly the same. And let's find out if I was smart enough with this modular arithmetic. Yeah, I'm not very much surprised, but it worked. So yeah, we learned modulo. I'm sorry, I made modulo arithmetics difficult, but I was not prepared for part 2, and I couldn't. That's why I couldn't prepare for explaining that to you. But really, if you are not aware about modular arithmetics, and I don't remember the English name for that, sorry, but in general, modular arithmetic, just Google that, read about that, but because this would save you ass on many puzzles. Many puzzles are just done modulo something. And the whole thing, which is called small Fermat theorem, which you learn on high school, or not high school, but on your university probably, it is all about this thing. So really, very useful in cryptography, very useful even to understand blockchain. Yeah, to understand how blockchain works. Actually, you may need modular arithmetics for how some stuff are done on low level. So very useful thing. Really learn about modular arithmetics, and also you can learn about this algorithm of select and unstable, because it's very often way faster than the whole sort, because it doesn't need to sort everything. It basically needs to figure out the mid value, and then it just wants to do single quick sort iteration to sort them out. So I think it might be even complexity may be just n, because I think it is first looking for the proper value, which would be log n, right? Find and index might be like O log n. I'm pretty sure this is what this, and then just separate would be just O then, I think. And because of that, it makes it that unstable would be O then some O odd and log n, but because n is bigger than it's again, and because of that, this is just O then. So I'm pretty sure this just O then instead of n log n. N log n is bigger. Okay, thank you very much for watching. Interesting stuff here. Also take a look at Nightly Features sometimes. See ya tomorrow. Bye.